Okay, today we are going to learn about density. So if you remember that we started learning about density last class, it was one of our intrinsic physical properties. So we're going to kind of walk through that and explain how it really looks and what it does. We're going to break it down more into specifics. So if we look at the molecular view of when we're talking about density, it's the closer the molecules are in a given volume, the greater the object's density. So least dense means that the molecules are kind of spread out and not all touching next to each other. But as we move over to being more dense, these molecules are more touching each other, stacked in close to each other. Okay? That's more dense. Okay? So when we start talking about density, there's two things that we have to account for. So density is a mass to volume ratio, basically. So our formula for that is going to be D equals M over V. So if we first look at this block area right here, the mass of it is 200 grams. Our volume is 100 cubic centimeters. So what is our density? We take our formula, so we take that 200 divided by 100, and our mass will give us 2 grams per cubic centimeter for density. Okay? So if we take this block and we cut it in half, what is the mass of it? So it's going to be 100 grams if we divided it in half. Our volume would be 50 cubic centimeters. Okay? So what's our density then? 100 divided by 50 based off of our formula would give us 2 grams per cubic centimeter. So you can kind of see a pattern already, right? So if we take this block and we cut it one more time and we cut it in half again, our mass now becomes 50 grams. Our volume would become 25 cubic centimeters. So our density, if we calculate it, 50 divided by 25 is going to give us 2. Okay? So you can kind of see how the numbers, the mass, the volume changes, but the ratio doesn't change in the sense of the density. It stayed 2. So if an object is cut in half, the density basically will stay the same. So when it says what type of property is density, this is intensive. So it doesn't matter the quantity we have, it stays the same density. Okay? So you're going to need to know how to rearrange this formula so we can solve for any variable, mass, volume, or density. So our calculation D equals M over V. Okay? Mass is going to be D times V, density times volume, and our volume is M over D. That's your basic algebra rearranging. Okay? So that's not hard. So then we go on to our example and we start applying it to a scenario or a situation. So on example number 1, it says a block of wood 3 centimeters on each side has a mass of 27 grams. What is the density of the block? So this is 3 centimeters on each side, so we need to calculate volume. To do that, volume is always length times width times height, because we have to adjust for the whole thing. So this is 3 times 3 times 3. So if we calculate that, that's 3 times 3 is 9, 9 times 3 is 27, and it's going to be cubic centimeters, because we did that 3 times for the 3 sides. So that's our volume. Our mass is 27 grams. So we know our formula is D equals M over V, so our mass, 27 grams, divided by our volume, 27 cubic centimeters, will give us a density of 1 gram per cubic centimeter. Okay? So remember, if you're doing a lot of math, make sure you circle or make sure I can figure out what your answer is. So on example number 2, it says, what is the mass of an object if its density is 2 grams per milliliter and its volume is 5 milliliters? So let's point that out. Volume, okay, really quick, can be either in cubic centimeters or milliliters, okay, either one. So it just depends on what your problem is giving you, but that answer could be correct for volume. So we are solving for this. Our equation is D equals M over V, okay? That's our original density volume. So if we start plugging in numbers, it says, what is the mass? So we have the density of 2. So 2 is going to equal, we don't know what the mass is, but we do know what the volume is, of 5. Okay? So when we're calculating this, If you can either rearrange this formula already, or you can just learn, you probably already know how to do that cross multiplication thing so you can solve for m. So 5 times 2, okay, is going to equal the 10. And our answer is going to be in grams because we are looking for mass. Make sure you give us the right unit. That way we know that you know what you're talking about, what you're weighing or accounting for. On example 3, it says, what is the volume of a liquid with a density of 2 grams per milliliter and a mass of 8 grams? So same setup, D equals M over V, okay? If you're comfortable doing the cross multiplication, that's what I suggest. That's going to be the easiest one that we use in class. So we just start plugging our numbers in. So density is 2. It's going to equal a mass of 8, and we don't know what volume is, okay? So how do we do that? We know that there's a 1 right here, so 8 times 1, okay? And then divided by 2, because we have to basically get rid of that. So V is going to equal 4 milliliters. And you know that it's milliliters and not cubic centimeters because that was what was given to you in the density formula. Okay? All right, going from there, we have one more example on the back that we can look at. It's example number 4. So it says, what is the density of a penny that weighs 2.49 grams, and when placed in a graduated cylinder filled with water, the water rose from 10 milliliters to 10.5 milliliters. So we didn't really talk about this yet. This is going to be known as displacement. So how much water moved, basically. So the water rose from one level to another level, to a different volume. So we have to calculate for that. So when we're looking at displacement, we take the initial volume, okay, and we take the final volume. So we have to take that and turn it into a problem. So 10.5 is the final volume, okay, minus the initial volume, which was 10 milliliters. So when we figure out what volume we displaced, it's going to be 0.5 milliliters, okay? So this is our volume that we're going to be calculating in with it. So then we still stick everything that we have into our formula, D equals M over V. So it's just that extra step to calculate for volume. So our mass was 2.49 grams, okay, divided by our volume, the displacement volume, okay, how much it moved, how much it raised the water, basically. Okay, so 2.49 divided by 0.5 milliliters is going to give you 4.98 grams per milliliter. Okay, so this is definitely something you need to know how to do, displacement. Okay, so it is your, if you think about it, it is your final volume minus your initial volume. Okay, write that out if you need to. That'll solve you for your volume. All right, so go ahead and pause the video right now and go ahead and do the on your own. And then we'll come back on and we'll check and see if you got the answers right. All right, let's see how you did. So the first one is, you just set up the same problem, D equals M over V. You've got a mass of 3.9 grams, okay, for that ethanol. And then it is with a volume of 5 milliliters, okay, this is for your ethanol. Okay, so we have to calculate for that, which should have given you 0.78 grams per milliliter. Okay, and then on the other side we had to calculate for the density over here. So for benzene, so I'm going to write that name down here so I don't get confused which one's what. Same formula, D equals M over V. 44 grams divided by our volume, which was 5, so 5.0 milliliters, same amount. Our mass comes out as 8.8 grams per milliliter. So the question was, which liquid is denser? So looking at these numbers right here, I know that benzene is more dense because it has a greater number. Okay, good. Hope you guys got that. So moving on to number 2, it says, what is the volume of your shoe if the density is 0.85 grams per milliliter and the mass is 60 grams? So set up your formula. We're going to do some cross multiplication today on this one. So your density is 0.85. It's going to equal, your mass is 60 over volume. We know that there's a 1 over here. So basically it's 60 times 1 divided by 0.85, which is going to give you 70.59 milliliters. And that's your volume. Alright, moving on from there, we have a density column. So we've learned about what density is, if they're more dense or less dense, and how to calculate it. So on here it says the density column, when several immiscible liquids are combined, okay, they form layers or a density column. So the liquids will order themselves according to their density. So if it has a really small density, it's going to be on top. If it has a really large density, it's going to actually go onto the bottom. So, and it kind of goes stacked up based off of that. So when you are looking at this charts down here, on these charts down here, so you are going to basically color in your graduated cylinder. So based off of the densities, is this going to be red? Is this going to be green? You're going to put them in order based off of their densities. Once you have the color coding in, then you're going to go and place all these objects in it and kind of put to the side. Is a granite rock down here? Is a plastic block down here? So go ahead and take a moment and color this in and label where the objects would fall in this density column. Okay? And then when you come back on, we'll check and see how good you guys did. Okay, so your column should look something like this. Okay? Your orange is on the bottom because it's the most dense, so heaviest, going down on the bottom. So you got orange, blue, red, and then green on the top. And then your objects that go in, your rocks on the bottom, because it is at 2.75. You've got your plastic block right here between these at 1.04. Soap at 0.9, and then your wood blocks on the very top, 0.65, because it is actually even less dense, that green, so it's going to be on the top floating. Alright, so that's density. So we will be doing a lab next class, but you will also have homework, a homework sheet that you should have picked up as you walked in that you'll be getting to practice more on these. If you don't get it, please come to tutorials and we'll talk about it. Thank you.